Hi, hello everyone. Myself, I am Mahendar Ramidi. I'm a senior mobile developer slash like a mobile architect. Today's my topic is securing healthcare at scale, DevSecOps for critical patient platforms. So, as a mobile architect over a decade in health technology, I have navigated the complex intersections of security, compliance, and patient safety while building platforms that serves millions of patients across cancer centers and different organizations, health organizations nationwide. This presentation shares how we implemented DevSecOps for my story. So this application is a award-winning trademark mobile health and cancer patients like a symptom tracking application. So this platform supporting active clinical trials at healthcare institutions. So the stakes of healthcare security. So generally in the health technology, the stakes are immensely high. The security failures aren't merely embarrassing incidents. So if you take any examples, there are a lot of security failures. So they are direct threats to patient lives and public trust. So whenever there is something happened in the healthcare industry that might affect a lot of patients, so consider this critical chain. A patient's chemotherapy relies implicitly on precise data transmission. So the integrity of life-saving clinical trials results in based on the what kind of data we selected, what kind of data we got, and deeply personal health information there in the healthcare applications, as we know. So in this landscape, the very concept of margin for error is eradicated. So the small error like affect a lot of patients' information, the PIA data leakage, those things. So we have to take care of all these security things considerable. Rely on the traditional security paradigms where the safeguards are related to the final pre-deployment checkpoint. It's not just in the healthcare industry. It is dangerously absolute. For us, security is not a future. It's like foundation upon which digital health solution must be built. Like when we like building the application, we considered all these security concerns. What kind of PI data is there? What kind of information we have to be secure while releasing the stores. DevSecOps represent a paradigm shift. So basically, it's not just a process; it's like a profound cultural and operational transformation. So strategically integrating security into every facet of healthcare technology lifecycle. So this means proactively embedding a robust security measures directly into the development phases. For example, modeling securing design principles throughout the continuous static and dynamic code analysis with automated CI/CD pipelines, catching vulnerabilities long before deployment. So basically, when we like deploy the applications in the DevSecOps, we are like putting like a security scans using Sonar Scope or like some other tools. So we scan all the application. We'll try to find before releasing the application, we'll try to find where are the loopholes, where are the security gaps are there. We identify by using those gaps. But operations are deeply infused in security places, like involving constant monitoring, automated compliance checks, proactive vulnerability management, and redefined incident response strategies. So ensure all unparalleled systems readability. Ultimately, DevSecOps cultivates a shared responsibility across all teams. So generally, like when we develop, like we have front end team, back end team, all the other teams are there. So we have to consider like each place where all the teams are working, what are the gaps, what kind of security, what kind of like sensitive patient data we have to be critical care to be considerable. We have to take care of all those things. So this historic approach ensures resilience, trust, and highest standards of patient safety in a constantly evolving threat landscape. Generally, the scammers are there. A lot of scammers. Everybody is trying to steal the data. With the data, like whatever data, like for example, if we use any patient information, those things like might affect in the industry. So we have to take care exactly what data we are collecting. We have to give security for the trust purpose. For the patients also need to be very confident on the application before using. So this is the healthcare security landscape. So first one is like a regulatory complexity. So when we HIPAA establishes baseline requirements, But clinical trials introduce FDA oversight, state level regulations, add another layer. So basically on top of HIPAA, we are adding another layer. For international institutions, introduce GDPR considerations also. Like for the international use, we are using the other considerations also. So attack surface, so healthcare data is uniquely vulnerable to attackers. Medical records sell for far more than credit card numbers because they contain information that can't be changed. So because of this, we have to be careful. So the third one is patient safety. Like when we build anything, so we have to take care of security failures can directly harm patients. Incorrect medication diagnosis, missed appointments or delayed treatment represent security failures with physical consequences. So these are the three things we have to be consider while we develop anything. So this is like a mobile health expands the attack surface. So data moves between patient devices and cloud infrastructure. Generally, like a patient enter the information by using like a REST APIs or anything. We just exchange the data between that whatever database cloud architecture we use, those things generally does, right? So those things like a patient data should be like very, we have to like encrypt all the patient data whatever we use. So they connect untrusted networks that may have another application with permissions that could access sensitive data. So we have to be careful whenever we access like untrusted networks. The offline requirements of healthcare applications add complexity. Patients need to access their health information even without connectivity. In hospitals with poor reception during travel or rural areas. So the mobile offline is one of the other challenge. So basically, we for this we can come up with zero trust architecture, identity as a parameter. So first we choose like a multi-factor authentication. So initial patient enrollment requires MFA tied with the verified health system credentials. Patient don't simply create accounts. They have provisioned through secure enrollment process. For example, when you create account, we have all this authentication to or some other things we develop. So device binding, after authentication, we cryptographically bind patient's identity to their specific device, prevent credentials theft from immediate compromising access. So this is like device binding is one of the other security we can build on top of multi-factor authentication. And the third one is like a biometric authentication. So by using fingerprints or Face ID, these two things, will add another authentication for the enrolled devices. Fourth one is like continuous verification. So generally by using tokens every 15 minutes, every 10 minutes, the token will refresh. So if the application need is ideal, the lifetime of the application will automatically kill that particular session. If they want again, they have to log in. So these four things we'll consider for the security. So this is end-to-end encryption architecture. So the data-centric security. So first one is device encryption. So as I told, device encryption before leaving a patient device, data encrypted. So the transit protection, encrypted transmission with certificate pinning. So the certificate pinning is another concept for the data encryption. So storage security, encrypted with hierarchical key management. The fourth one is authorized access. So decryption only authorized devices can do. So this way, the before sending the data, this is the encryption decryption method we use to secure the patient information. So the key DevSecOps implementation, first one is end-to-end encryption. So the zero trust architecture with hierarchical key management and device binding is the first thing. Second thing is automated security testing. So CI/CD pipelines with static analysis, dependency scanning, and dynamic testing. So these are the things we can do and do automated security testing. So offline first design. So secure local storage with the conflict resolution and data integrity controls. So this is the third step. The fourth step is compliance as a code. So automated validations of HIPAA, FDA, or other regulatory requirements we have to be considered. So fourth one is real-time monitoring. So continuous security monitoring with automated incident response we have to be considered. So these are the 5 key implementations we have to be considered. So the other one is the automating compliance infrastructure as a code. So healthcare regulations feel like immovable constraints. So DevSecOps inverts this relationship, treating compliance as a dynamic requirements that automation can continuously verify. So the IPA requirements IPA requires a encryption that rests in transit, Our infrastructure code enforces this by refusing to prevent storage of network without appropriate encryption configurations. So generally, the policy as a core tools validate infrastructure against compliance requirements before the application deployment. Attempting to deploy database without encryption triggers immediate rejection with clear explanation of which compliance requirement would be violated. So these things we will do as part of the process. So this is the layers of the CI/CD. So first one is we'll do like a static analysis. The static analysis, we analyze the code, the catches like hard-coded credentials, and also the SQL injection, any insecure crypto implementation we'll find. Second one is the dependency scanning. So in the dependency scanning, we'll check like every third-party library for known vulnerabilities. If there is any vulnerabilities, we'll block the deployment. Third one is dynamic testing. So dynamic testing stimulates attacks against running applications. So authentication bypass and authentication failures will test. Fourth one is container scanning. So we'll scan the containers based on the images, verify security best practices. And fifth one is API security. So what are the backend APIs? We'll test unauthorized access rate limit. So we will check all those things. Offline first architecture challenges. So these are some challenges for the offline first mobile development architecture. So secure local storage. So full device encryption as a baseline protection. So this is the first one. So application level encryption required with keys derived from patient credentials. So secure element integration and hardware protected keys also we have to implement. So biometric authentication, the other one. So conflict resolution, vector clocks track modification history, operational transformation maintain eventual consistency, complete audit trails for all offline changes. So these are the conflict resolution things we have to take care. So continuous security monitoring for this application. So we have to be secure. These are the 4 steps. So application monitoring. So we have to be always monitor the application. So the second one is infrastructure monitoring. So observe like a system behavior and is any potential attacks we have to be, and also all the authentication attempts, any in the network, unusual traffic generates, any security tells, these are the things we have to take care. The other one is audit log analysis. We have to be detailed records of all security relevant events. Automate analysis identifies suspicious pattern authentication, data access and configuration changes. So anything happen, we have to check this also. The other one is behavior analytics. So machine learning models learn typical patterns for individual patients and clinicals. So is any like those kind of things, models or anything is doing. So we have to take care and continuous monitoring all this process. So platform success metrics. So these are the platform success metrics. So first one is like enhanced patient engagement. Second one is HIPAA compliance. Third one is zero data breaches. Fourth one is uninterrupted availability. So the platform consistently achieves significantly higher patient engagement. So this is one thing for the enhanced patient engagement. Second one is like we have to check like HIPAA validations, unwrapping, uncommitment, underwaiving commitment builds profound trust on both patients and healthcare providers. So these things we have to be checked. Zero data breaches. So we have to take care like what kind of data, and also every time we have to be careful with the patient information. Fourth one is powered continuous monitoring and automated incident response. This is the one thing we have to care for. We have to do every 24 hours and 7 days a week. So response framework. So detection analysis is the first thing. So we have to be like check any detections. So this thing we have to check. The containment is the second thing. So any limit impact isolated effect by systems, revoking compromised credentials. So those things we have to check. So eradication is the third thing. Remove threats from systems by fixing vulnerabilities, improving security controls and updating configurations. So recovery, the fourth thing, validate threats are eliminated, restore systems can secure state and gradually store service while monitoring recurrence. So the last one is post-incident analysis. So security as a foundation. DevSecOps in healthcare represents more than implementing security tools for following compliance checklists. It reflects a fundamental philosophy that security, privacy, and patient safety are the foundational requirements rather than features to be added. So the MyStory platform demonstrates that robust security practices and excellent user experience aren't opposing goals. Success requires cultural change alongside technical implementation. Security becomes everyone's responsibility. So the patient trust depends on security. When patients share intimate health information, so when they rely on application during vulnerable moments, when they trust systems with data that could literally save their lives, robust security isn't optional. Thank you. Thank you for giving me this opportunity. Yeah, if you have any questions, please send an email.